Welcome to our demo video showcasing the two professional versions of USB stabilizer. Have you ever dealt with storage devices that seem unstable? These are the drives that are failing but haven't completely crashed yet. You might see them in BIOS, but not in the operating system, or they might appear briefly before disappearing or causing your PC to hang. Some may respond with errors, while others work so slowly that copying files is impossible. USB stabilizer solves these problems by connecting between the unstable drive and the computer. The stabilizer device emulates the connected drive, making the computer believe that it's working directly with the drive, when it's really working with the stabilizer. The computer sends read commands to the stabilizer, which then separately reads the source drive. If the connection with the source drive is interrupted for any reason, it is automatically re-established. The computer remains unaware of any issues, ensuring that drive instabilities do not cause Windows to crash, hang, or drop the drive. The emulated drive appears in Windows as a regular mass storage device, so we can use absolutely any software to work with it. We'll start by using FTK Imager, a tool frequently utilized by forensic investigators, with USB stabilizer taking the place of traditional write blockers. The source drive identifies correctly, as if it was connected directly to the PC. As we image the drive, we can see exactly what's happening in real time. The speed graph shows when the source drive slows down, indicating drive degradation. Now we are running into bad sectors. For every bad sector, the stabilizer waits for a customizable amount of time, and then issues a hardware reset to reinitialize the drive, forcing it to drop the bad sector and move on. This dramatically reduces further drive degradation and speeds up the recovery process. Despite the drive being reinitialized every couple of seconds, Windows never loses the connection and our recovery continues. The source drive can even be physically disconnected in the middle of the recovery. The stabilizer continues to emulate the disconnected drive and our recovery does not abort. Reconnecting the drive allows the recovery to continue as if nothing happened. At the end of the imaging process, the drive is turned off automatically, and the correct logging is maintained in both the imaging software and the stabilizer control panel. Next, we'll recover a degraded NVMe SSD using RStudio and USB stabilizer. When SSDs develop read instability issues, they often appear in disk management, but quickly cause the PC to hang, leaving us unable to proceed. With USB stabilizer, we simply connect the SSD through an adapter and configure the read instability handling process for SSDs. Whenever the SSD starts hanging, it is automatically repowered, and the recovery process continues seamlessly. Every unstable drive behaves differently, and a USB stabilizer provides a series of if-then algorithms to help anticipate and manage these behaviors. For instance, if the sector map shows that the drive usually has 4 bad blocks in a row, we can set up an algorithm to preemptively skip 3 blocks after encountering a single bad block, effectively accelerating the processing of bad areas by 4 times. Another example are storage devices, which enter the so-called offline state, where they immediately respond to all read commands with errors. Repowering the drive is the only way to exit this state. We can do this by pressing the Repower button, but a better way to handle this is to configure an algorithm to automatically execute a repower based on consecutive read errors. USB Stabilizer Pro is what we've been showing so far, and it only has a single USB port. The high flexibility of the USB interface allows connecting almost any type of storage device, so we can work with SATA drives, SD cards, NVMe SSDs, and even SAS drives, through widely available and inexpensive adapters. However, adapters, particularly SATA to USB, usually slow down error handling. The USB Stabilizer 10 Gigabit is our latest flagship device, featuring native ports for USB, SATA, and M.2 NVMe. As its name implies, it connects to the computer using 10 Gigabit USB-C. It has 3 independent channels, so it can work on 3 drives at the same time. Channel A supports either USB-C or M.2 NVMe. Channel B supports USB-A, and Channel C supports either USB-A or SATA. When working with one channel, the maximum speed exceeds 800 megabytes per second, and the combined total speed for all 3 channels is over 1 gigabyte per second. Its speed of working with degraded hard drives is also greatly improved. Here we can see a comparison of USB error handling speed. The 10 Gigabit device uses newer and quicker types of USB resets, which allow it to be approximately 2 times faster when working through bad sectors. An even bigger difference can be seen when working on SATA hard drives. The single-channel USB Stabilizer Pro must work through an adapter, which substantially slows down error handling, while the 10 gigabit device supports SATA natively. Error handling speed is extremely important because degraded drives will only work for a finite period of time before they crash completely. So, the faster we work, the more data we'll recover. No single reset method can work for all cases. Some highly degraded drives may occasionally fail to process some types of resets and continue to hang, requiring a repower to be done instead, which is slow and harsh on the drive. The 10 gigabit USB stabilizer offers 4 different types of USB and SATA hard drive resets. Lighter resets work faster and are suitable for most cases, while heavier resets are more likely to be processed by severely degraded drives. Additional algorithms allow for further customization in case the storage device fails to respond to a reset or repower. The 10 gigabit USB stabilizer also shows the current consumption of connected drives, which is useful for diagnostics. We can easily see when there is a short circuit on any of the power lines or if the drive doesn't consume any current, indicating electronic failure. That's all for this demo video. Thank you for watching.